Welcome to Let's Do It 5.9. In this LDI, we're going to take a look at a modified box plot. So to create a modified box plot, first thing we need to know about is what's called the 1.5 times interquartile range rule. And basically what this does is it gives us a way of determining whether or not a data point is an outlier or not based upon the interquartile range. And we say that any value that falls 1.5 times interquartile range above Q3 or 1.5 times interquartile range below Q1 is considered an outlier. So let's take a look at what this says. Let's just draw kind of a generic box plot for a second. So here's our box, and let's put the median in, say the median falls walk that, and then let's go ahead and put our whiskers in, okay? Now typically in an unmodified box plot, like we think about the age data that we looked at on our earlier example of box plots, which this one is not too unsimilar to that I'm drawing, what we do is we just draw the whiskers, okay? Let me go ahead and move that median so it's a little more representative there, right about there. And we just do that, and we just, in no consequence or consideration whatsoever whether or not an outlier exists. Well, what we're going to do now is we're going to come in here and we're going to make a new metric. We're going to make a metric which is our interquartile range. So if you think about this distance from there to there being our interquartile range, we're going to take that distance and then we're going to take again 1.5 times that distance. So that distance, then that distance again, right? But not quite, about half of it, okay? So that's 1.5 interquartile ranges if you take a look at those two red lines that I've drawn there. So that's roughly 1.5 interquartile ranges. Now we take that distance and we say, okay, any data point that falls beyond that distance, in other words, that's more than 1.5 times our interquartile range above Q1 or below Q3, excuse me, I said that backwards, above Q3 or below Q1 will be considered an outlier. So this red line that I've just drawn here, hopefully you see now that that red line right there, the length of that red line is 1.5 times the interquartile range, okay? And that's kind of our measuring stick that we're going to use to determine whether or not something's an outlier. So clearly, in this distribution, whatever data points reside above that would now be considered an outlier, all right? So how do we finish up our box plot once we've done that? Well, here's kind of the tricky part, and we're going to let the calculator take care of this for us in the future, is we'd have to redraw this whisker. And what has to happen with this whisker is it's now drawn, let's go back into black here, let's get rid of the current whisker. It's drawn in such a fashion as that it goes out and it stops at the last data point prior to the suspected outlier. So let's say the last data point that fell prior to the suspected outlier was right there, and now that's as far as the whisker goes. And then out here, where our suspected outlier is, we no longer would have a line segment, but instead what we'll do is we'll put some sort of a point, usually a circle or an asterisk, to indicate to our viewing public that that point is in fact an outlier. Okay, so now that's the basic idea behind it. Let's go ahead and do a modified box plot of our actual age data so we can see how it actually works when we do it in practice. Typically you don't do these by hand, you allow the calculator to do them for you. So let's get the calculator up here, and let's go to second stat plot. Let's turn on plot 1. Let's go down and let's select the first box plot that you see in our list, not the second one. You see the one with the dots on it there? That's a modified box plot. That's the one we want to use. And notice a new thing opened up down the bottom saying the mark. What mark would you like to use to indicate outliers? And we'll go ahead with the default, which is the square there. It's kind of a style thing. You get to pick whichever one you want. So once we've done that, we're going to go and do a zoom and a 9 for zoom stat. And notice we get the following box plot. And as in the drawing that we did earlier, there is a distance for new distance now for the whisker, and it stops right here. At that point right there, that is not the maximum. No, that's the last data point before we hit the 1.5 times interquartile range. So let me show you a little bit by hitting trace here. Maybe it'll make more sense. There's the minimum, still at 16. There's Q1 at 19.5. There's the median at 22. There's Q3 at 32.5. That didn't change. But now notice 48 is the last value that shows up in the distribution prior to there being an outlier. Now there are two outliers in our distribution, one at 54 and one at 59. But the thing to notice is that that last outlier, 59, is also the max in the data set. The maximum is not 48. The maximum in this data set is still 59. It just happens to also be an outlier. Okay, so let's take that information and see how we can use it when applying it to this LDI. This is LDI 5.9, 5-number summaries and outliers. It says for each of the following modified box plots, report the corresponding 5-number summary and the list of values for all or any outliers that exist. So let's go ahead and do that. So we're going to have to just do a little bit of guessing here, but we'll get a good shot at what these numbers are. So looks like the minimum here, I'd roll with, say, 18. That's probably a good guess at what the min is. If you said 17 or 16 or a number's close to that, you would be fine. Okay, I wouldn't go down as far as 15, obviously. That's getting a little bit sketchy there. Looks like Q1, we'll go with Q1 being at 20. Okay. Looks like the median on this one is falling right about at 40. Looks like our Q3, I'd roll with 80 for the Q3 here. And looks like the maximum on this one is at 90, okay? All right, so value for any or all outliers. Does not look like there are any outliers in this box plot. It's looking just like a standard box plot, but that's okay. If it was drawn using the modified box plot rules, it'll look like a standard box plot, and that's okay. Okay, let's get that 20 and the 40 down so a little closer to where they need to be there. Okay, cool. All right, let's go take a look at this one. In this box plot, looks like our minimum is down around 10. Looks like Q1, I would say Q1 is around 20. Looks like the medium is pretty much going to be at 50 there. I'm thinking 50 looks good, right? Looks like Q3 is at 60. Okay, now where's the maximum at? Is the maximum at 80 or is it at 90? Well, hopefully you're seeing, get the pen over here for you, you're seeing that value of the maximum, doing red for you here, is also an outlier. So that's our maximum right there, but it's also an outlier. It's both, okay? And that appears to be showing up at around 90, okay? All right, let's take a look at the next one. Looks like this one's off screen a little bit, but that's okay. We can still make this fit. We'll just do the numbers off to the side here. Okay, so it looks like in this particular case that the minimum is down around 10. Okay, so I'm going to put the numbers here so you can see them. So, and looks like Q1, we're thinking, I would say Q1 is at around 20. Looks like Q3 is showing up around 30. Q4, there's no Q4, what am I talking about? So the min's at 10. Oops, I missed Q1. That's my problem here, isn't it? Let's go ahead and fix that real quick. The median was at about 20, right? Q3 was at 30. The min was at 10. And let's get this number in right here. I'm going for 15 for Q1. I left out Q1 there. Sorry about that. All right, now, what's this value right here? In other words, what's this number where that line segment is there? Well, that's the last value prior to the start of the outliers, okay? So that's not any concern at all in terms of this list that I'm making. On the other hand, this value right here, which is 60, that's represented by an outlier, and it looks like about, I'd go 62 or 63 is also an outlier. But with respect to the 5-number summary, the next number that I need to put down here is, let's say I'm going to go with 63. If you said 65, that's fine, but I think it's a 63. Okay, now what are my suspected outliers? Well, my outliers appear like they're at 60 and 63. It looks like I've got two outliers in this case. All right, now just a word of warning. There was some differences depending on when your textbook was published in terms of what this actual LDI looked like. So if yours looks different than mine, I apologize for that, but some of them came out a little bit different depending on when they ran the publication. As long as you get the idea, that's the main thing, okay? So if yours are slightly different than mine, no big deal. Don't worry about it. Alrighty then, I'll see you all back here for LDI 510.